Here we shall have a discussion of previous year questions of chapter 4, that is multivariable calculus, partial differentiation and applications. First question we have, if u is equals to log of x square plus y square by x plus y, prove that dou u by dou y is equals to 1. So by Euler's theorem, just find out whether it is a homogeneous function or not, and by that you will get the degree of the function f of x comma y, that is u. Then by Euler's theorem we have the formula x into dou u by dou x plus y into dou u by dou y is equals to n into u, where n is the degree of the function. And but here you have to prove the practically that x into differentiation of the function u with respect to x plus y into differentiation of function u with respect to y is equals to 1. So by practically you need to prove this. Just convert this logarithm into exponential form, you will get e power u is equals to x square plus y square by x plus y. The next question, if x plus y plus z is equals to u, y plus z is equals to uv and z is equals to uvw, then evaluate dou of xyz by dou of u comma v comma w. Just you have to find the value of this. This is a finding Jacobian. This type of problem I have explained in my videos, and here you need to convert all the x, y, z into in terms of u, v and w. So z we have the equation in terms of u, v, w. You have to convert the equations of x and y in terms of u, v and w. So for that, just substitute the value of z in the second equation, then you will get the y in terms of u, v and w. So here you will get y plus uvw is equals to uv, and send this uvw to the right hand side, then it becomes minus. Then similarly find the equation for the x, substitute the values of y and z in the equation 1, then you will get the equation of x in terms of u, v and w. Then differentiate the equations x, y and z with respect to u, v and w, then find the Jacobian, you will get the final answer. The next question, show that u is equals to x square into e power minus 5 cos hz and v is equals to x square e power minus 5 sin hz, w is equals to x square plus y square plus z square minus xy minus yz minus zx are functionally dependent. So functionally dependent means Jacobian is equals to 0. It means you have to differentiate the function u, v, w with respect to x, y and z, then you will get the value as 0. Just show that these functions are functionally dependent. If dependent, find the relation between them. If these functions are functionally dependent, then find out the relation between these three functions. The next question, find the maximum of x square plus y square plus z square such that 2x plus 3y plus z is equals to 14 using Lagrange's multiplier method. So you have to find out the maximum of the function. This is a function f and this is the pi. Lagrange multiplier method, we have the formula as capital F is equals to small f plus lambda into pi. So this is a small f function and this is a pi. So send this 14 to the left hand side, you will get minus 14. So 2x plus 3y plus z minus 14 is equals to 0 is the pi function. Then f is equals to x square plus y square plus z square. So differentiate the function capital F, that is capital F is equals to f plus lambda into pi. Now differentiate the function capital F with respect to x, y and z equal to 0. Then you will get 3 lambda values. From that you solve those equations, you will get the values of y and z in terms of x. So substitute in the pi equation, then you will get the x, y, z values. That will be the maximum. So this is a Lagrange's multiplier method. Then next question, if u is equals to x square minus 2y and v is equals to x plus y plus z and w is equals to x minus 2y plus 3z, then find the dou of u comma v comma w by dou of x comma y comma z. So here you have to differentiate the functions u, v and w with respect to x, y and z. So this is what finding the Jacobian. Here x, y, z, all the equations are there in terms of x, y and z. So you have to differentiate these three functions with respect to x, y and z. And the next question, if f of x comma y is equals to ln of x square plus y square plus tan inverse of y by z, then prove that dou square f by dou x square plus dou square f by dou y square is equals to 0. So here you have to differentiate the function with respect to x and y. It means at first find out dou f by dou x and dou f by dou y. So at second step, you have to differentiate the function dou f by dou x one more time with respect to x. Then you will get the second order differentiation dou square f by dou x square. Then similarly you have to differentiate dou f by dou y with respect to y. Then you will get the second order differentiation of dou square f by dou y square. Then add those two values, you will get the value as 0. So we have to prove that this sum of these two functions is equals to 0. And the next question, a rectangular box open at the top is to have volume of 32 cubic feet. Find the dimensions of the box requiring least material for its construction. So rectangular box is open at the top. So you have to take the dimensions of the rectangular box as xy, 2yz and 2zx. So these are the dimensions of this box, and its volume of it's having the volume of 32 cubic feet. Nothing but xyz is equals to 32. So xyz, that is a volume, and nothing but it's a function f is equals to xyz minus 32 is equals to 0. So it's a pi. So pi is equals to xyz minus 32 equals to 0. And then function comes as xy plus 2yz plus 2zx is a function small f. So therefore capital F is equals to small f plus lambda into pi. Now you have to differentiate the capital F function with respect to x, y and z. Then you will get the three equations. Solve those three equations, you will get the values of x, y and z. So that will be the dimensions of the box. The next question, if u is equals to x plus y by 1 minus xy and theta is equals to tan inverse x plus tan inverse y, then find dou of u comma theta by dou of x comma y. Hence prove that u and theta are functionally dependent. Also find the relation between them. So given u is a function and theta is also a function, you have to differentiate u and theta with respect to x and y. So that is what find out in the Jacobian. And then we had to prove that u and theta are functionally dependent. So the functionally dependent, nothing but Jacobian is equals to 0. So you will get the value of this as 0. And then after you have to find out the relation between these two functions. So this problem I explained in my previous videos. I'll provide the playlist link in my description box. Check it. So this is what you will find the Jacobian, and we will check whether they are functionally dependent or not. And if they are functionally dependent, we will find the relation between them. And the next, if x is equals to r cos theta and y is equals to sin theta, then show that dou square r by dou x square plus dou square r by dou y square is equals to 1 by r square of dou r by dou x whole square plus dou r by dou y whole square. So you have to prove this. Just you have to differentiate the r with respect to x and y. So convert these two. It's in x and y. So convert in terms of r. Then differentiate with respect to x and y. And finally you need to prove this. And the next question, x is equals to, if x is equals to c cos u and cos hv, and y is equals to c sin u sin hv, show that dou of x comma y by dou of u comma v is equals to 1 by 2 c square of cos 2u minus cos h 2v. So you have to differentiate the function u and v with respect to x. You have to differentiate functions x and y with respect to u and v. So that is what find out in the Jacobian, that is dou of x comma y by dou of x comma u comma v. So finally you will get, you have to prove that the Jacobian is equals to this value. Then next, if u is equals to f of y comma y minus z comma z minus x comma x minus y, then show that dou u by dou x plus dou u by dou y plus dou u by dou z is equals to 0. So here you just take the y minus z and z minus x and x minus y as the variables r, s and t. That means y minus z is equals to r, and z minus x is equals to s, and x minus y is equals to t. So when you take those functions, you differentiate r and s and t with respect to x, y and z. So then after, by chain rule method, you can write dou u by dou x as dou u by dou r into dou r by dou x, so that dou r will get cancelled. Again you will get back to dou u by dou x. So this is what by finding the chain rule method. So here the function dou u by dou x can also be written as dou u by dou r into dou r by dou x plus dou u by dou s into dou s by dou x plus dou u by dou t into dou t by dou x. So here we are differentiating r, s and t functions with respect to x, y and z. So finally, similarly find out the dou u by dou y, and then after dou u by dou z, add all those three values, you will get back to 0. So this similar type of problem I explained. And the next question, if x is equals to uv and y is equals to u plus v by u minus v, determine dou of u comma v by dou of x comma y. So we are finding out in the Jacobian, differentiating the functions u and v with respect to x and y respectively. So there the functions x, y are in terms of u and v. So here no need to convert the equations. We have the one property of the Jacobian as dou of u comma v by dou of x comma y can also be written as 1 by dou of x comma y by dou of u comma y. It means after differentiating the functions x and y with respect to u and v, when we do the reciprocal of it, you will get back to this function. So here differentiate x and y with respect to u and y, then you will get the final value. Just write in the denominator as 1 by dou of x comma y by dou of u comma v value. So you will get back to dou of u comma v by dou of x comma y. The next question, if u is equals to x plus y minus z and v is equals to x minus y plus z and w is equals to x square plus y square plus z square minus 2yz, show that the functions are functionally dependent. Nothing but differentiate u, v, w functions with respect to x, y and z, and then finally prove that these three functions are functionally dependent. It means find the Jacobian and you will get the value as 0. So that is what you are proving, they are functionally dependent. And the next, the temperature T at any point of x comma y comma z in space is T is equals to 400 xyz square. Find the highest temperature on the surface of the unit sphere, that is x square plus y square plus z square is equals to 1. So we have the unit sphere formula as x square plus y square plus z square is equals to a. As it's mentioned that unit sphere, unit nothing but 1. So x square plus y square plus z square is equals to 1. If they don't mention, you need to write the formula on your own. So t is a function of that 400 xyz square, that is a small f. So small f is equals to 400 xyz square. You have to find out the point at which the temperature is highest, and the pi is equals to x square plus y square plus z square, and you send this 1 to the left hand side, it becomes minus 1, and that minus 1 is equals to 0. So pi value is this, and this is the f value. So we know that Lagrange's multiplier, that is capital F is equals to small f plus lambda into pi. So you have to differentiate the capital F function with respect to x, y and z. So then you have to solve those equations, you will get the values of x, y and z, and that will be the highest point of the temperature. And the next question, show that the functions f of x comma y is equals to x square minus 2xy plus y square plus x cube minus y cube plus x power 5 has neither a maximum nor minimum at point 0 comma 0. So we have the condition for getting a neither a maximum nor minimum point, that is ln minus m square should be less than 0. Then we can say that the function has neither a minimum or maximum point. So the point they given as 0 comma 0, you need to prove that the function is having neither a maximum nor a minimum. So you have to find out L, N and M. So we have the condition ln minus m square is less than 0, So L nothing but dou square f by dou x square. It means we are differentiating this function with respect to x for the 2 times. Second order differentiation, that is dou square f by dou x square. That gives the value of L. Then next find out the value of m, that is dou square f by dou x dou y. It means dou f by dou y is differentiated with respect to x, and that you will get dou square f by dou x dou y. That is the value of m. And n is equals to dou square f by dou y square. It means we are differentiating the function with respect to y for 2 times. Then you will get the second order differentiation of the function with respect to y as dou square f by dou y square. So then the condition ln minus m square should be less than 0. So we had to prove this. And the next, if x is equals to r cos theta and y is equals to r sin theta, show that dou of r comma theta by dou of x comma y is equals to 1 by r. So x we have in terms of r and theta, and y we have in terms of r and theta. So for this, do x square plus y square. When you do squaring of these two equations, you will get squaring and adding of these two equations. You will get x square plus y square is equals to r square cos square theta plus r square sin square theta on the right hand side, and on the left hand side you will have x square plus y square. So from the two equations, you will take r square as common. You will get r square of cos square theta plus sin square theta. So cos square theta plus sin square theta is 1. So r square of 1 is r square. So x square plus y square is equals to r square. Then r is equals to under the root of x square plus y square, or you can write it as x square plus y square whole to the power of 1 by 2. Then you got r in terms of x and y. And next we have theta. So for theta, you divide the equation 1 by equation 2. It means x by y is equals to, that is on the left hand side. On the right hand side you will have r cos theta by r sin theta. R will get cancelled, and cos theta by sin theta nothing but you have cot theta. So x by y is equals to cot theta. You can even convert it into tan theta, that is y by x is equals to tan theta. So from that, theta is equals to tan inverse of y by x. So theta you will get in terms of x and y. Then after you have to differentiate r and theta equations with respect to x and y. Then you have to prove that the value of this is equals to 1. Or directly you had, by using the Jacobian property, you can directly find out the values of x and y. You can differentiate them, and with respect to r and theta, then you have to do the reciprocal of it. Then you will get the final as dou of r comma theta by dou of x comma y. And the next, if u is equals to f of r, where r square is equals to x square plus y square, and then show that dou square u by dou x square plus dou square u by dou y square is equals to f double dash of r plus 1 by f dash of r. Just you have to prove this. You have the function r, you have the function u, that is f of r. So r is given as r square is equals to x square plus y square. So you have to prove that the function, differentiating the function u with respect to x and y. Then you have to prove it as f double dash of r plus 1 by r into f dash of r. And the next question, find the area of a greatest rectangle that can be inscribed in a ellipse x square by a square plus y square by b square is equals to 1. So take the dimensions of the rectangle, and that is inscribed in the ellipse. The x square by a square plus y square by b square is equals to 1. This is a pi, and take the values of x function f. We are finding the area of a greatest rectangle, and that is inscribed in the ellipse. So by Lagrange's theorem, capital F is equals to small f plus lambda into pi, you will get the final area of the greatest rectangle. Solve those equations, and finally you will get the values, and substitute in the function, you will get the area of the rectangle. So formula you have to use is capital F is equals to small f plus lambda into pi. So these are the these are the previous year questions of the Unit 4 chapter, and in this mostly repeated topics are Jacobian and functionally dependent, and finding maximum or minimum either by two variables or by Lagrange's theorem, and finding Jacobian, and then functionally dependent, and then partial differentiation, simple partial differentiation. And these are the most repeated topics here. and I have explained all the topics of this chapter, multivariable calculus, and I'll provide the playlist in description. Check those videos. Thank you.